Hello. In this lesson, we're going to begin our study of geometry. And so first, probably share with you where the word geometry comes from and what it's going to entail. So Wikipedia defines geometry as geometry from the ancient Greek geo, earth, and then metro, implying measurement. It's a branch of mathematics concerned with questions of shape, size, relative position of figures, and the properties of space, specifically lengths, areas, and volumes. So geometry concerns itself specifically with measurement and measurement of different figures. Geometry is probably one of the first forms of mathematics besides just basic counting. So it was kind of the real birth of formal mathematics. It is heavily dependent on definitions and logic, believing that if you start with a few set of axioms or laws, you can build up to a larger set of findings from that. And so our first definitions that are going to guide us, well, if we're going to be measuring things, we have to be able to say where something is located, and that's what we call point. So a point is a location. It has neither shape nor size. It is essentially zero dimension because it has no shape or size. We name them with a capital letter. So for example, this could be called point A. When I have 2 points and I connect them, I have what's known as a line. A line is made up of points. It has no thickness or width. There is exactly one unique line through any 2 points. We name lines in a few ways. We can use the letters representing the points that are on the line, or you can use a lowercase script, kind of like an italicized letter. So we could name this line PQ, it could be called QP, or we could call it line M. If you use PQ and you don't write line before it, you need to draw a line over the top of it with arrows extending each direction to show that it is a line. If you use the word line before it, you don't need to draw the arrows. It would kind of be redundant. The most common ways you'll see, though, are those three: saying line M or saying the points with a line denoted above it. A line is one-dimensional because it has like a left-right dimension, if you will. The two-dimensional form is known as a plane. A plane is a flat surface made up of points that extend infinitely in all directions. There is exactly one plane through any 3 points, as long as those points are not on the same line. We name planes by using a capital script or like italicized letter, or you can name a plane by the 3 points that make up the plane. So there's a variety of ways that we could name the following plane. We could call it plane K, or we could call it plane BCD. The order in which you list those letters isn't important. There's no preferred one over the other. You just need to list at least 3 points that make up the plane. So 1 point is what's needed to make a point. 2 points make a line. 3 points make a plane. That's two-dimensional. 3 dimensions, we start to call them figures or shapes. Next vocab words: collinear. Co meaning with. Linear meaning with on the same line. So points that are collinear are on the same line. Points that are coplanar are with each other on the same plane. So like codependent, with dependent, the prefix co means with, together. Points that lie on the same plane are coplanar. So if two points are on the same line, we say they're collinear. If they're on the same plane, we call them coplanar. Here are some example type questions that we could ask just to make sure you understand the definitions of these words that we're going to be using a lot. So here's a figure for you. Give 2 different names for a line containing point Z. So point Z is the one right here below the plane B. How could I name line Z? Well, I could do it, it's just asked me 2 ways. So I could do ZR, that would be one way. It also is named by the L, so I could say it's line L. Those are 2 different ways that I could name that line. Give 2 different names for the plane. Well, I can see it's script B, so I could call it plane B. I'll do my best script, maybe kind of a cursive B. And then I need to know, or I could name 3 points, as long as those 3 points are not on the same line. So I could call it plane X or Y, but then I could not use R, because X, Y, and R are all on the same line. I could use W. That would be a way to name that plane. Are W and Y collinear? So let's look at where these, so W and Y, are they collinear? Yes, they are on the same line. Are W and R collinear? Let's erase. Are W and R collinear? So this is where a couple people get confused. Could there be a line between those 2 points? Yes, there could, but until it is drawn, we cannot assume that there is a line. So currently there is no line connecting W and R, so they are not on any line that is currently in existence. So no, they are not collinear at this point. Could they be? Absolutely, because they're 2 points, but they are not collinear at this point. Are W and R coplanar? Yes, they are certainly on the same plane. They are both on plane B. Are W and Z coplanar? No. W is on B and Z is not on that plane. Could they be on the same plane? Yes, they most certainly could. There definitely exists a plane that would contain W and Z, but currently there is not, so no. Other vocabulary word is intersection. Intersection is the set of all points two or more figures have in common. That's what the intersection is. Two lines intersect at a point. So in the picture I've shown here, line L and line M intersect at point P. Two planes most often intersect at a line. So plane A and plane B intersect at line R. Two shapes are the three-dimensional type version for geometry. Two shapes can intersect at a plane. So it kind of builds up. There's a nice level of dimensions going on here. Two one-dimensional figures cross at a zero-dimensional point. Two two-dimensional planes cross at a one-dimensional line. Two three-dimensional shapes will cross at a two-dimensional plane. So where two dimensions cross, if they're the same dimension, they're going to intersect at a dimension one below where they currently exist. Most often. It doesn't, two planes may not actually intersect. If they were parallel to one another, we call them kind of skew. They may not intersect. We're talking about the most often, the most frequently occurring occurrence. Example with this type of vocabulary. Well, how many planes are in the following picture? There's plane X, that's this flat surface. And then I need to look, well, there's the bottom of this shape, but the bottom of that shape is just X again. So the bottom doesn't get counted twice. So there's the bottom X, and then there's 1, 2, 3, 4, 5 sides along this shape. So there are 6 planes in total. There's the bottom and the 5 sides of the figure that is sticking above plane X. Where does plane GDF, let's color that in. So GDF is right here. Where does GDF intersect plane X? Plane X is this piece of paper right here. It intersects it right there, which is line GF. So it intersects it at line GF. Two planes intersect along a line. Where does the line LM intersect plane X? So let's erase again. Line LM is right here. Where does it intersect plane X? It intersects plane X at point L. You can just say L as well. Where does line LM intersect line JH? So where does line LM, is the one I just had, intersect JH? JH is over here. So if I go looking, JH and LM are not intersecting. So nowhere. There are no points of intersection. Gonna give you a chance to try. I'd like you to name a point that is collinear with JD on the same figure we just had a second ago. And then where does plane GDF intersect plane GHD? Pause the video now, come back after you have had a chance to try. First question, name a point collinear with JD. JD is right here. A point that is on that line as well is point K. So point K. Where does plane GDF, let's use color, so GDF, GDF, and GHG, GHD, where do they cross? They cross right there. They have GD in common, so they'll intersect along line GD or DG. You can list them in any order. That's the first half. That's a lot of our vocabulary. Now we're going to start to get to kind of the measurement part of geometry. So we said earlier that geometry comes from the root words for earth and measurement. Measurement was the main form of mathematics for early civilization. So being able to measure was completely fundamental to their civilization and culture. How would you define the distance between 2 points? That's an interesting question. It's almost so basic, it can be kind of hard to describe. So maybe pause the video for yourself. Write down the definition. How would you define the distance between 2 points? And then we'll see how mathematically we define it. So if you want to try it for yourself, pause the video. Otherwise, I'm going to show you. We define the distance between 2 points to be the length of the straight line segment that is connecting those 2 points. So if there's 2 points in existence, the distance between those 2 points, so if I had 2 points right here and here, the distance between them is the length of that segment connecting it. That's what we mean. We mean if you drew a line between those 2 points, a line segment, then the length of that line segment, how far you'd have to go, is what we define the distance. And geometry is very particular to definitions, so you have to pay very close attention to the definition. It's very much kind of like the study of law, where law relies a lot on the words in each law. So what does distance look like in one dimension along a number line? What would you say the distance formula for the number line should be if I asked how far apart are P and Q? If Q is located at location x2 and P is located at location x1, you might think for yourself what it'd be. Here's what the book says. The book says the distance between those 2 points is just the subtraction of the 2 points, and we'll take the absolute value in case that ever would be negative. But if you're assuming a positive number line, this number would always be positive, or not always positive, but at least more positive than the one on the left. So you could always do x2 minus x1 as long as it was a true number line. But if it was a different system, you would maybe want to write that you should take the absolute value in case you ever had a negative, because distance is always going to be positive. So distance in one dimension along a number line is just the subtraction between those two locations. And then we take the absolute value, so my distance is positive. What does the distance formula look like in 2 dimensions now? Well, we go back to the definition. This is something you'll do a lot in geometry. Remember that the distance between 2 points, that's not a great line segment. Actually, I have, there we go. It's the length of the segment connecting it. So I want to know how long is that blue segment. Well, the problem with it right now is it's at a slant, right? How do I find the distance if it's at a slant? I can actually make a right triangle out of this. So that and that. And the idea is, hey, that is a right triangle, and there's a theorem that allows me to calculate the slant, the hypotenuse length for a right triangle. It's the Pythagorean theorem. So I'm going to use the Pythagorean theorem here in order to find this blue hypotenuse length. But in order to do that, I need to get these lengths. So I'm assuming this red point is at x1, y1, x being the x coordinate of the first point, y coordinate of the first point. This I'm assuming to be the second point, so it's the x coordinate of the second point and the y coordinate of the second point, because we usually read graphs left to right. So the first point we get to would be this one, and that would be the second point. Well, what is this length right here? Well, this is x1, and if I came down here, this is x2, and we said, hey, that's the one-dimensional distance formula. How do I find how far apart those are? That's just x2 minus x1. And because it's a number line, I don't need to take the absolute value. Likewise, this right here, well, this would be y1, and over here, this would be y2. So how tall is this? It's just y2 minus y1. And now that I have the 2 legs, I can do the Pythagorean theorem. So let's call this, I don't know, d for distance, right? So a squared would be x2 minus x1 squared plus y2 minus y1 squared. That's like a squared plus b squared equals your distance squared. I don't want the distance squared, though. I want the actual distance. So how do I undo the square? I take a square root of both sides. I would write plus or minus, but there's no such thing as a negative distance, so I'm only going to take the positive case, and so I would say the distance is equal to the square root of, I'm going to write this all, actually let's go back, well this will be fine, of x2 minus x1 squared plus y2 minus y1 squared. And that is the distance formula in 2 dimension. It's just the Pythagorean theorem special case. Find the x distance, find the y distance, and run the Pythagorean theorem on it. How do I find the x distance? I subtract the x values. How do I find the y distance? I subtract the y values. The book just gives it to you, and it shows it to you, and it's this. It says, if you have 2 points, PQ, how do you find the distance between them? You do the square root of x2 minus x1 squared plus y2 minus y1 squared. It's just the Pythagorean theorem. That's how we find distances. The last thing that we find when we're measuring two things is the midpoint, halfway between them. On the number line, the one-dimensional midpoint formula, how do I find halfway between two numbers? We use this a lot when we were graphing quadratics. If I found the two x-intercepts, how did I find the vertex halfway in between? It was the average. So I add them together and I divide by 2. That will give me the midpoint. That's what it looks like in one dimension. In two dimensions, we'll go back to our figure. Again, I want the midpoint. So I want to know where is halfway between these. Well, let's think. If it's halfway between these 2 points, it has to be halfway between the x's and halfway between the y's. So let's go and look. What would be halfway between the x's? Well, this one is x1, this one is x2. So where would halfway between be for x1 and x2? It would be right here. It would be x1 plus x2 divided by 2. That would be its x-coordinate. How do I find the y-coordinate? Well, the two y-coordinates were y1 and y2. How do I find halfway between y1 and y2? I add them together and divide by 2, and that will give me the coordinates of the midpoint. The midpoint's coordinates are just going to be the average of the x values and the average of the y values. So if I want halfway between 2 points, I take the average of the x coordinates, and that will be halfway between the x's, and then I take the average of the y coordinates, and that will be halfway between the y's, and that will therefore then be halfway between the 2 points. Hopefully that makes sense. It's just a two-step, one-dimensional one, because it's in 2 dimensions. We'll do one problem that asks us to do both, the distance and the midpoint. So consider the following line segment. I want to know what's the length of the segment and where's the midpoint for that segment. So let's do the distance first. I'm going to show you the distance formula. We'll use it, and then I'll just show you, you could have just drawn a right triangle and done the Pythagorean theorem on this as well. But let's use the distance formula first. So the distance formula says that if I want the distance between any 2 points, it's x2 minus x1 squared plus y2 minus y1 squared. Well, let's label these things. This is x1, this is y1, this is x2, this is y2. Now I just plug things in and run the formula. Distance is equal to square root, x2 is 8, x1 is 2, plus y2 is 5, minus y1 is 1 squared. Distance is equal to the square root. 8 minus 6, or 8 minus 2 is 6. 6 squared is 36, plus 5 minus 1 is 4. 4 squared is 16. That will give us the square root of 52. Because that's not a perfect square, that's going to be an irrational number, so we're going to have to approximate it with a decimal, because that will technically go on forever without repeating. And it'll be 7.21 units, because we don't know what it's measuring right now. Distance is one-dimensional, so we just say units. It's not units squared, not units cubed. So 7.21, that's if you use the distance formula. You could have always just made a Pythagorean theorem question too. Just draw out a triangle in here. How far is this? Well, 8, this is 8 for x, this is 2, so this is length 6. This is 5 high, and this is 1 high, so 5 minus 1, this is 4. And then you just do the Pythagorean theorem with it. 6 squared plus 4 squared equals distance squared. 36 plus 16, there it is. That's just going to be 52. So you can always just draw the triangle in there and do the Pythagorean theorem. That's all the distance formula is. So there's the distance. Now I want to find where the midpoint is. The midpoint is the average of the x's for the x-coordinate, and then the y-coordinate is the average of the y's. Has to be halfway between the x's and halfway between the y's. Well, our x-coordinates were, what, 2 and 8? So what's halfway between 2 and 8? Well, add them together, divide by 2, that's going to be 5. So the x-coordinate has to be a 5. Halfway between the y's, the y-coordinates were 5 and 1. So 5 plus 1 divided by 2. Halfway between 5 and 1 is 3, because 5 plus 1 is 6. 6 divided by 2 is 3. So the midpoint should be at 5, 3. Let's see if that looks right. 5, and then 3. Looks like it'd be right there. And that would be halfway between. 5, 3. 5 is halfway between 8 and 2. It's 3 each way. 3 this way, 3 that way. And then 3 is halfway between 1 and 5. It's 2 up and 2 up. So that would be the midpoint. And that is how you find the distance between any 2 points and the midpoint between any 2 points. I'm going to ask you to try a slightly different midpoint question as our last one. So the last one for you to try is a little bit more of a challenge, just slightly. If I'm going to give you the midpoint on this one though and ask you what's the end point. So I'm telling you the point 6.5, 4 is the midpoint of AB. A is at 2.7. I want to know where is B located so that 6.5, 4 is going to be the midpoint. There's a couple ways to do it. I'd like you to think about it. So pause the video now for maybe a minute and a half, 2 minutes. Unpause it once you've given it a try. I want to see how you did. So pause the video now, please. First way you could do this is just by using the midpoint formula. You know that 6.5 has to be halfway between the x-coordinates. Well, the x-coordinates are 2 and 6, so x plus 2 divided by 2 has to equal 6.5. Then you solve by multiplying by 2 and then subtracting 2. The x-coordinate has to be an 11. And then same for the y's. 4 has to be halfway between 7 and y. So y plus 7 divided by 2 has to equal 4 because 4 is halfway between. It has to be the average. Multiply by 2, you get 8. Subtract 7, you get 1. B would have to be located at 11, 7. So that's one way of doing it, is to just use the midpoint formula. You know the midpoint, but you don't know the coordinates, so you have to solve for x and y. The other way is just kind of think about it as a slope. M is halfway, so how do I get to M? Well, I first go down 3, and then it looks like I'm going to go right 4.5. And then if M is the midpoint, I just do that again. If I go down 3 more, I'm at 4, I'm going to end up at 1, and then I go right 4.5 more. I'm already at 6.5. If I go right 4.5 more, I'm going to be at 11. So another way of doing it is going to be, what would I say, 11? So it shouldn't be 11.7, 11.1. I don't know why I said 7. It should be at 11.1. And I'd be at 11.1. So there's two different ways of doing it. You either do it by using the midpoint formula, or you can just count, continuous slope. That's it. Thank you very much and have a good day.